Okay, this is example 5.1. Let's look at this example. This is a good little example where we're trying to find for this area shown, determine the first moments with respect to x and y axes and the location of the centroid. Okay, so the first thing, this is a composite plate. So I'm going to try to draw this in a way that makes sense. So here I'm going to draw this thing, right? So we have this shape, okay, it's equal to, say, I'm going to try to kind of state a scale here, right? It's going to be equal to this block plus, I'm going to extend this axis quite a ways out here. It's going to be plus this triangle, right? Plus this half circle minus this full circle. So for the sake of clarity, I can call this body 1, 2, 3, and 4. So what I'm going to do is I'm going to turn around, I'm going to make a table. And this is how I would suggest doing this. And then I'm actually going to switch over to Excel here in a second. But I'm going to say, okay, so the body, right? And we're going to have the area. We're going to find the X bar, Y bar, X bar area, and Y bar area, right? And then, so we have 1, 2, 3, 4. And then we're going to take the sum. That's supposed to be the sum. And then we're going to make this table, and we're going to fill out this table. So let's go over and let's fill out that table in Excel. Okay, let's figure this out. This body 1. Well, what do we have for that body 1? Its area is simply the length times the width, right? So 80 times 120. Okay, the body 2, the area, and no, let's stick with body 1. What is X bar? It's going to be right in the middle, right? So the X bar of this one is going to be 60. The Y bar of this is going to be halfway up here, so it's going to be 40, right? And now the X bar, this is simply, it's literally X bar times, I can do the little time symbol, times area. Fair enough, right? And the Y bar is the Y bar times area. Okay. Body 2, what is the area? It's going to be 1/2 times base, which is going to be 120 times 60. This area of that, right? The X bar, well, it's 1/3 from the distance from here to here. So that's going to equal to 120 divided by 3. And the Y bar is going to be 1/3 down in this direction. You'll notice this is going to be a negative. So this needs to be minus 60 divided by 3. Because it's down here 20 down. And so the area, actually I'm just going to copy these two all the way down. So then it's the area. Now let's look at this third one. So what is the area of that? It's a half a circle. So it's going to be pi. So in Excel, pi times r. R is 60 squared, but it needs to be divided by 2. Right, so that's our area. What is our X bar? Well, X bar is just kind of right in the middle, right? So that's going to be 60. What is our Y bar? Well, okay, the Y bar, we know it's 4r over 3 pi, but that's 4r over 3 pi from here. So for us, it's going to be equal to 80 plus 4 times r, which is, r in this case is 60, divided by 3 times pi. So that's my X bar, Y bar, and then it automatically is going to figure that one out, so that's kind of convenient. And then for 4, what is our area? Well, it's the area of a circle, which is what? Pi times r. In this case, it's 40. Oh, except for it's not pi. It's pi times 40 squared. But what did we do here? Well, this is a negative, so this is a subtracting area. So I'm going to come in here and I'm going to say the area is minus that. The X bar and Y bar is just in the middle, right? So X bar is going to be 60, and Y bar is going to be 80. And there we have our nice table. Now we need to do the sum. So this needs to be the sum of, oops, this stuff. and we need all the sums of these different values. It turns out these two, just for clarity's sake, I can get rid of those so no one gets hung up on things that are unimportant. Okay, and so there we have that, and we have that table. I'm going to copy and paste this table and go back to the other software. Okay, since I filled out this chart so lovely in Excel, I got rid of the handwritten chart. But there we go, we have our chart. Now, what we're supposed to do is we're supposed to first find the first moments with respect to y and x-axis. So what are those? Those are qx and qy. Well, what do we have? So qx is integral of y dA, right? But for this, it's going to be equal to the sum of y times a. So what is that? Well, we have that right here. Boom. So therefore, qx is equal to 5.06 times 10 to the 1, 2, 3, 4, 5 times 10 to the 5th. And qy is going to be the other one, 7.58 times 10 to the 5th as well. So there, boom, we have our answers for qx and qy. But now, we're not done. That's the first part. And honestly, those are just, I mean, it's nice to know, but those are just kind of an interim step. Really what we want to do is we want to find the location of the centroid. Well, how do we do that? Well, it comes down to this, right? X bar times area is equal to the sum of X bar area. So therefore, X bar is equal to the sum of X bar area over the this area. This is really the sum of the area, right? So the sum of the area. Okay, well, we have all these things right here, right? So therefore, X bar is equal to the sum of X bar times area, so it ends up being 75, 76, 99 over sum of the area, which is right there. So 13, 8, 28.3. So X bar is, in this case, 54.8 millimeters. And, oops, sorry. You can do the same math to figure out Y bar. So Y bar sum of the area is equal to sum of the Y bar area, right? So Y bar is equal to, in this case, it ends up being 36.6. 36.6. So realistically, where is that? So X bar 54.8. So this is somewhere along along this axis-ish, and Y bar 36.6. So I don't know. So I think we're claiming it's around there. Does that seem reasonable? Yeah, sure. Why not? So there you go. So our X bar, you have our X bar, and you have our Y bar. And this is how you're going to do it. I'd almost suggest doing a lot of these problems in Excel. I'm doing it on this software so I can show you a little bit better. But this lends itself really well to Excel and to doing these spreadsheets.